So,
Okay, excellent. All right, then. I'll go ahead and get started. Welcome, everyone, to a special live stream tonight. I'm here with astrophysicist Dr. Hugh Ross of the Old Earth Creation Organization Reasons to Believe. We're going to be talking about the New Horizons mission to Pluto and what that means with regard to creation, what the implications are. There are various young Earth creationist organizations that maintain that the New Horizons science data indicates that Pluto is in fact a young world, according to the paradigm that they have, their interpretation of Genesis, which puts the universe at about 6,000 years of age. And we're going to talk to Dr. Ross tonight about some of the arguments that they bring out in favor of that viewpoint and how they analyze the data. So, welcome to the program, Dr. Ross. Thank you for joining us.
hey, my pleasure.
I've been following your work for a long time, so it's really great to be able to talk to you finally, and apologize again for that rocky start there. New Horizons was just an amazing accomplishment. It was a real coup for NASA in many ways. I mean, I grew up in the 70s and the 80s studying astronomy, trying to learn what I could about the solar system. And back then, when I was first getting into that, we didn't even have good pictures of Uranus and Neptune. And then finally, Voyager got out there in 1986, 1989, gave us some great pictures. But the best thing we still had of Pluto, I've told people, was the famous 1978 photo where the Charon discovery with the moon. And I've told people it kind of looked like somebody took a handful of grits and threw it at a wall. That's about what it looked like. We didn't have very good resolution on that. So New Horizons really brought that world to life for a lot of people. And it was a real public relations coup for NASA, I think, too, because people just fell in love with it. Pluto, for some reason, has got a lot of excitement around it. So it was good to see that. One of the things I noticed, and I kind of figured that this was going to happen as soon as some of the data started coming back, we got some results that we didn't quite expect. There were some physical features on Pluto that were a surprise to scientists, and that made a buzz in the media. There were some features, the famous heart of Pluto, what they call the Tombau Regio area,
Right.
Sputnik Planitia. It looked like it had been resurfaced relatively recently. And Alan Stern, who actually led up the New Horizons mission, did some interviews, and he said, this is a real shock to us. He says, this looks like it could be maybe 10 million years old, if that. You know, Pluto itself is supposedly about 4.5 billion years old. And I immediately thought, okay, well, the young earthers are going to be real happy to hear that. And, you know, they've produced some articles since on that. Answers in Genesis has. Creation Ministries International has done a couple videos on it. One they entitled Pluto, Another Young Planet. That was the main one they did. And then they did kind of a teaser, a real short one, which I think spacecraft results verify Pluto is young. So they were really taking that information and running with that. Based on what you know and what New Horizons returned to us, do you agree with that? Is there any merit to their assessment that Pluto is actually a young world?
Well, I've debated the leaders of both Christian Ministries International and Answers in Genesis several times, and they always play the same tactic, which is to cite an anomaly that doesn't fit the rest of the data and the understanding. And just because something is anomalous, they presume that overturns the whole paradigm, when in fact, that's how science operates. Science advances by pursuing things that don't quite fit our understanding, and we pursue it to a deeper depth to actually resolve that. And every time we resolve an anomaly, we find more anomalies. But we know we're on the pathway to truth if the new anomalies we find when we resolve the old anomalies are smaller, less numerous, and less problematic. And that really is the bottom line story of our research on Pluto. And yes, we only had these very fuzzy images of Pluto from ground based telescopes, but there is actually another data point that is cited in the peer reviewed papers, and that is the fact that Pluto has occulted stars. And stars are point sources. So when Pluto orbit passes over a star, you actually get to detect the atmosphere. Because instead of the star blinking out suddenly, it takes a little more time, which tells you that it's going through an atmosphere of the planet. So we knew Pluto had an atmosphere before the New Horizons got there. The surprise of the New Horizons, however, is it demonstrated that the loss of nitrogen from the planet was about 10,000 times less than what we had presumed from the occultation measurements. And so that was a big surprise, which means that the loss of nitrogen and methane right now is very low. While methane is close to what we expected, it's nitrogen. Nitrogen is a predominant component of Pluto's atmosphere. So that's off by 10,000, which tells us that right now things are really stable in the Pluto Charon system. However, orbital analysis tells us that the Pluto Charon system, if people aren't aware of it, you've got Pluto and 5 moons. But there's one really big moon orbiting Pluto, and that's the moon Charon. And they're tidally locked. So these two bodies are close enough together that their tidal interaction forces the same face of Pluto to always face Charon and the same face of Charon to always face Pluto. However, and again, this is another principle. In order to understand these details, you want to exhaustively read the scientific literature on this. When I went to the younger sites, it's like they haven't really kept pace with the scientific research that's going on here. And one of these papers just got published in Icarus in April of this year. So that's one of the newest papers that are out there, and basically making the point that thanks to the New Horizon data, and the analysis is continuing, tells us that there is a significant change in the orbit of Charon and Pluto. And right now, Charon's got a highly circular orbit around Pluto. But over the course of 1 million years, that orbit varies from being extremely elliptical to being virtually circular. Right now, it's in its circular mode. But if you go back just 800, 900,000 years ago, it was highly eccentric. And it's a high eccentricity that drives heating, tidal heating inside Pluto. And so a tidal heating event could explain why we see a resurfacing of part of the surface of Pluto. And when you read the younger articles, they're basically saying we look at that little heart-shaped region on Pluto, we don't see many craters at all. And they say if it's old, we should see a lot of craters.
Right.
What they forget to tell their readers is that elsewhere on Pluto, we see plenty of craters.
Mm-hmm.
So that's evidence that the rest of Pluto's surface is actually geologically old, but there's one region that's geologically young. And as this paper published in Icarus demonstrates, when you take into account the impurities in the liquid water below the surface of Pluto and take into account the changes in the orbit of the Pluto-Charon system, this resurfacing is well understood. We know it happened less than 10 million years ago. It could even be as recent as 1 million years ago. So there's nothing in the peer-reviewed literature that would suggest even a hint of evidence that we're looking at a young Charon or a young Pluto. Both objects measure to be about 4.5 billion years old.
Right. I do remember, too, that I think it was Alan Stern's interview with the Christian Science Monitor. He was careful to say that the fact that we have a newly or recently resurfaced area does not mean that the entire body itself is young. So I
That's
think
right.
kind of anticipating maybe that objection. Cratering on us, the concentration of cratering, that's one of the ways that planetologists, astrophysicists judge the age of a body, isn't it?
Well, for a body as distant as Pluto, yes. We got bodies closer to us. We have better dating methods. But for something as far away as Pluto, yeah, the cratering rate doesn't give you the age of the planet. What it does is it gives you the age of the surface features. And if there's geological activity, we would expect those surface features to be younger than the age of the planet itself. Now, how you get the age of the planet is through calculations of how the planet was formed and the subsequent dynamics. That's where we get the most accurate measurement of the age of the Charon Pluto system. And the fact that you've got this big moon orbiting a fairly small, large asteroidal body tells us that they likely form from two bodies crashing into one another. You get a merger event and you get the formation of this big moon. That's how our moon formed. Our moon formed as a result of the proto Earth colliding with the planet Theia, and you get a bigger Earth and you get the moon. And so, and you just like you can work out the dynamical history of the Earth Moon system and get an age for the moon, we can do the same thing to get an age for Sharon. And it's consistent with Sharon being a little more than 4 billion years old. So that's our most reliable method. The
Right.
cratering simply gives you an estimate of the last time there was a geological resurfacing of that part of Pluto's surface.
Right. Okay. So that does show that that whole Tomball Regio area that was recent, maybe
Right.
an impact event. Some have speculated might have caused that, or
It could be an impact event, but this paper published recently in Icarus says
mm,
it's more likely due to the tidal history. And,
right.
so given that the fact that the orbit goes from circular to elliptical, you're
Mm,
going to get much stronger tidal forces in the past than you have today. So they're basically saying we think it's predominantly tidal heating, but they also claim there's a significant contribution from long-lived radioisotopes like uranium and thorium.
mm,
And that's one thing where the young Earth creationists were mistaken. The density of Pluto is higher than what they claimed because they were saying it can't be very many radioisotopes. Well, if you actually use the correct measures of the density of Pluto, you can have significant quantities of long lived radioisotopes. And that would be another contribution to the heating. A third contribution would be the leftover accretion heat that you get from the merging of the events that led to the Charon Pluto system.
yeah. I was thinking about that too. I didn't know how long that could last. The accretion heating you were talking about in a body that old.
Well, I mean, we still have significant accretional heating in the
Mm,
interior of the Earth. Actually, the leftover accretional heating in the Earth is greater than the heating we get from the radioisotopes.
oh
And
wow.
obviously, we know the Earth's interior is hot enough that we have a liquid iron core.
Mm. Right. And that's I think that's kind of surprising for some people. They just think that, after all these billions of years, these bodies should have cooled off by now. So they're kind of surprised when they see that sort of thing.
Well, that's where the young Earth creations are correct. If you use a highly simplified model, you'd expect more rapid healing or more rapid cooling. But this is where this paper in Icarus, I can give you the title of the paper. It
Hmm.
says the tidal thermal evolution of the Pluto Charon system.
Hmm.
And it's the most sophisticated calculation to date, where they say the previous attempts to try to measure the age of the system and measure when these resurfacing events took place were not properly taking into account the impurities in the ice and the liquid water in the interior of Pluto, and nor were they taking into account the higher order eccentricity terms. So they did a detailed calculation, not just over the past few thousand years, but over the past million years of what we'd expect due to the changing eccentricity of the orbit. And so this is the best calculations that's been done to date, and basically tells us that the water interior to Charon uh, is completely frozen. And that's what you'd expect over 4 billion years, that it would take that long to become completely frozen. And the frozen interior of Charon is consistent with the dynamics of the Charon Pluto system. So the fact that Pluto still has liquid water in its interior, but Charon doesn't have any, it's all frozen. This means that the two bodies must be more than 4 billion years old.
Right. I think too that especially people who aren't real familiar with the subject, they get the idea that when you're talking about a planet, you're talking about a moon, you're talking about basically a big rock in space. That's about it. Just a solid body, which, more or less like our moon. But when we're dealing with a lot of these objects in the outer solar system, especially, they have differing compositions. They're not just
Very
solid
much.
objects. Like you were talking about liquid water. From what I understand, they believe that Pluto has a solid, like a silicate core, and that's
Right.
surrounded by a liquid water ocean and then ice over top of that. And then you've got that surface dynamic that can change because you've got that movable material underneath of it.
Yeah, to give you the numbers, with Pluto, it's about two-thirds silicate rocky material
Mhm.
and one-third frozen water with impurities and some liquid water. With Charon, it's about a 50-50 split, a 50% silicate material and 50% water in a frozen state.
Okay. Yeah, I hadn't heard that about Sharon. That's interesting. I know Alan Stern at New Horizons had mentioned too that ammonia dissolved in Pluto's subsurface ocean could probably help as a kind of an antifreeze mechanism to keep that liquid, over the years. So that's another part of it. Pluto's surface, I kind of think of it as almost like an ice cream cake that has frozen, melted, and refrozen many times and in many places. Uh, Depending on how close it is to the sun, its surface ices they sublimate, and then when it's farther away, kind of gives it that atmosphere, and then when it gets farther away, it falls to the surface again like a chemical snow there. Another aspect is cryovolcanism, and I don't know if you could talk about that for a second, maybe for people who aren't familiar with it.
Well, cryovolcanism is kind of what you see in Jupiter's moon Io. It's so close to Jupiter that it experiences substantial tidal heating. And it's that tidal heating that drives the volcanism. And so if you look at Io's surface, it looks relatively young because the volcanism keeps resurfacing the surface of Io. But as you go farther away, like if you look at the four large moons of Jupiter, Io's the closest, Callisto is the most distant. But the farther away you get from Jupiter, the weaker the tidal heating. And there you see that as you move away from Pluto, we notice that the resurfacing of the surfaces of these moons gets less and less, and the resurfacing looks older and older, and the cratering gets greater as you move away from Jupiter. And so this is well explained by the differential tidal heating. And likewise, we can use those same principles on Pluto and Charon. Uh, Unlike Jupiter, Jupiter doesn't get much tidal heating from its moons because it's so much more massive than its moons.
Right.
But in the case of the Pluto Charon system, Charon is 12.5% the mass of Pluto. And so Charon exhibits significant tidal heating on Pluto. And so, and then, one of the features they've also discovered, because they're saying, hey, given the eccentric orbit of Pluto, it should warm up considerably when it gets closer to the sun during its eccentric orbit. But one of the things that got published an article published in Science is that they have found cyanide, hydrogen cyanide, in the upper atmosphere of Pluto, and this actually significantly cools the planet. And that's their explanation for why the escape of nitrogen is like 10,000 times less when they estimate it. Is like there's a couple of molecules, one of them cyanide, another one is H2C2, that basically acts like a refrigerant that's cooling the atmosphere. And therefore, like young Earth creation has said, all the nitrogen should be gone. But if you actually look at the detailed model, over the course of a little more than 4 billion years, it looks like Pluto has only lost 6 centimeters thickness of frozen nitrogen off of its surface. And it's got way more nitrogen than that. But they also look at the erosion that's been taking place on the ice mountains on the surface of Pluto. And
Mhm.
young Earth creationists have cited those ice mountains, saying, hey, this is an anomaly. Well, when we look at those mountains, it's clear they've been eroded to a far greater degree than what you'd expect if Pluto has only lost 6 centimeters thickness of nitrogen ice. But again, given the changing orbit of the Charon Pluto system, you'd expect a much greater loss of nitrogen at different points in the orbit of the Charon Pluto system than we're presently measuring. And so that's completely consistent with the erosion rates we see on the ice mountains. Again, everything's consistent. with both bodies being a little more than 4 billion years old.
Right. And it's interesting what you were talking about there too, because even though this has been since 2015, we're still learning things. We're still
We're still
processing
learning things, definitely.
and
Yeah.
modeling all of this stuff. Um, Again, and for people who aren't as familiar with it, it may be hard to understand what New Horizons was. Effectively, I would kind of describe it this way: we basically made a high tech bullet, loaded a bunch of science equipment on it, and shot it through the Pluto system. And it gathered all the data it could, while it was there. Basically, within a day, I think it was when it was in range of the
Right.
planet, going about 46,000 miles per hour, and it just wasn't able to do detailed science study. So, for us to find some anomalous features and then say, well, this overturns well-established scientific paradigms, I think is extreme. As a young Earth creationist want to argue, we really need to send an orbiter mission back, something like a Cassini or a Galileo, that can spend a couple years doing some in-depth analysis of Pluto and
Yeah, this was not an orbital, it was simply a flyby. And incidentally, when they prepared the mission, they were expecting to see some anomalies. It would have been far more surprising if there were no anomalies. It's like, okay, we spent all this money and we didn't learn anything.
yeah, so they like to be surprised. Scientists like to be surprised. They like to find new things. Um, One other thing that young Earth creationists have pointed to is Pluto's moon system. You've mentioned it's got 5 moons, Charon being the very largest. It's significantly larger than the other moons. They're really very tiny. They're potato kind of shaped, irregular shaped. They look very much like broken off pieces of something larger, from something in the past. And the Creation Ministries International in particular, they mentioned that as these moons orbit Pluto, they kind of tumble through their orbit. They're not
Yeah.
tidally locked. And Hydra, the outermost moon, spinning wildly, like 88,
Right.
89 times. They suggest that this is indicative of recent creation. Can you comment a little bit on the structure of the moon system and what that does or doesn't tell us?
Well, the 4 other moons of Pluto that have been discovered orbit considerably more distantly from Pluto than Charon does. As you mentioned, they're tiny moons, they're not big moons.
Mhm.
And, to get tidal heating, what tidal heating means is that the gravitational pull of Pluto on the near side of the moon is quite a bit stronger than the pull on the far side. And so that explains why you get a lot of tidal heating with a body like Charon, because it's a big body. And so there's a difference between the distance to the near side and the distance to the far side. But with these tiny moons orbiting far away from Pluto, the tidal heating is negligible. Uh, you're not going to get much of a difference between the near side and the far side. And astronomers were quite surprised by the discovery of these 4 tiny moons. On the other hand, as we look at the moons of Neptune and Uranus and Saturn and Jupiter as well, we see that a lot of the moons are not indigenous; they're captured. And so, given that there are 5 big asteroid and comet belts orbiting the solar system, you'd expect a body like Pluto to capture some small bodies. And indeed, that's what we see. And so, astronomers would love to figure out, okay, are these bodies captured? Are they indigenous as a result of the merger event? And if they're captured, when did the captures take place? How did they take place? These are all unanswered questions to this date. And yeah, this paper that got published in Icarus a couple of months ago, it's not going to be the last paper. More is coming out. But that's one of the big objectives of the planetary astronomy community. Let's see if we can figure out what's going on with the dynamics of these tiny moons. But the fact that some are tumbling rapidly and don't seem to be experiencing the effects of tidal heating, that's exactly what we'd expect, given their distance from Pluto and how tiny they are. And, you know, kind of the consensus in the planetary astronomy community, they think is likely that maybe all or at least some of these bodies are captured bodies. And when you get a captured body, chaotic things happen.
Right. Okay. And you were mentioning kind of the asteroid belt there. Pluto is part of what's called the Kuiper belt. It's
Right.
most people know that there's an asteroid belt between Mars and Jupiter, but many may not know that there's actually a debris field, for lack of a better term, in the outskirts of the solar system, too, the Kuiper Belt, of which Pluto is one of the larger objects. One of the Answers in Genesis articles, Danny Faulkner, whom I know you have debated before in the past,
Right,
he
right.
makes the point or alleges that this Kuiper Belt is a very crowded area. So he was saying that Pluto should have much more impacts, much more cratering than it does. I don't know if you can maybe correct my understanding on this. I understood that while the Kuiper Belt does have a lot of objects in it, thousands of objects, and probably a lot more of really small ones, they're spread out over a vast area. And I wouldn't think that Pluto would encounter very many things all that often. I don't know what you would think about that.
Well, Pluto is on the extreme inner edge of the Kuiper Belt. And so, yeah, the density of Kuiper Belt objects is a lot less at Pluto's orbit than it is if you were to go out another billion miles away from the sun.
Mm,
But there's three other asteroid and comet belts. I mean, you got the scattered belt, you got the Oort cloud, you got the main belt. The main belt that everybody's familiar with between Jupiter and Mars, it's the
mm,
smallest of the five asteroid and comet belts that are orbiting the solar system.
mm,
So uh, yes, we are going to get some collision events. As I've already mentioned, you got this one region where we don't see any major cratering events, but the rest of the surface of Pluto, we do.
mm,
And so the cratering we see there uh, is consistent with those regions having an age of about a billion years.
mm,
Now, what Danny Faulkner is pointing out is even if you look at the regions beyond that heart shaped area, we should be seeing more craters. Yes, we would if it hasn't had any thermal resurfacing going on throughout the entire 4 billion year history. But no astronomer believes that. We believe there has to be resurfacing going on. In fact, what's a bit of a surprise, we see so many cratering events that it tells us there's been no major resurfacing of the region of the surface of Pluto outside that heart region for the past billion years. We would expect it that maybe we should have less craters given the age of the system rather than the number we see. So it's the exact opposite of what Danny Faulkner is implying.
right. You would kind of think the rest of Pluto should look more like the Tomball Regio area if that were true. It shouldn't be that unique part of the planet.
Yes.
So that's interesting there. Um, One of the things that, as far as cratering goes, this has always been something, and it was one of the things that provoked me when I was a young Earth creationist to really reconsider things. Why would we find cratering in the first place on these bodies? If God spoke them into existence instantaneously, not so very long ago, why do we find comets and asteroids and those kinds of things in the solar system? Or why do we find dust and gas clouds? Why do we find effectively, kind of like I was saying before, debris in the universe? It's like, well, God didn't clean up his construction site very well. It's like, why would we find these things? To me, I don't know what you think, but to me, that does not sound consistent with the young Earth instantaneous recent creation idea.
Well, what I appreciate about Danny Faulkner is he does admit that there are problems with the young Earth model, uh, not just in the solar system, but across the scientific disciplines. So he cites the fact that, for example, we look at the moon, you see a lot of cratering. You look at Mercury, you see a lot of cratering. And,
Mm,
Mercury is interesting because it's so close to the sun. So it's not going to get the degree of collisions that the moon gets.
mm,
But young Earth creationists have an answer for that. They claim that during Noah's flood, there was a major solar system disturbance, and that explains all the cratering that we see on Mercury, Mars, and on the moon.
mm,
But there's a problem with that proposition because when we look at the cratering on Mars and Mercury and the moon, we can see that the craters are eroded and the degree of erosion. And the degree of erosion is different for the three bodies. And so you should be able to look at the craters in the three bodies and come up with a consistent age for those three bodies.
mm,
And we do, basically telling us that most of those craters happen about 3.8 to 3.95 billion years ago.
mm,
And because you can see I mean, if it was the Noah's flood, we shouldn't be seeing any erosion at all, but we
Mhm.
do see erosion. Mercury has got a very tiny argon atmosphere.
Mhm.
And even though it takes so long to rotate, it does erode the craters over billions of years. Likewise, the moon's got a very tiny argon atmosphere,
Mhm.
much tinier than Mercury's. And that too erodes away the craters. And so we can get an age estimate that's fairly accurate. Some of the craters measure to be young because we see very little erosion,
Mhm.
but the vast majority of them, 90%, indicate that they were formed by a massive collision event, thousands of colliders happening about 3.8 to 3.9 billion years ago. And the argon itself is an indicator of age because the only source of argon is potassium 40 decay.
Mhm.
And potassium 40's decay rate, its half life, is almost nearly 40 billion years.
Mhm.
And so it takes a long time to build up a significant quantity of argon. Earth's atmosphere is about 1% argon, and
Mhm.
that 1% is consistent with potassium decaying for about 4.5 billion years.
Mhm.
Likewise, the argon we see in the moon's atmosphere and Mercury's atmosphere is consistent with both bodies being about 4.5 billion years old.
Yeah.
And in the 2 hour television debate I had with Danny Faulkner,
Mhm.
we had an agreed upon panel of evangelical Christian astronomers adjudicate the 2 hour debate.
Mhm.
And they were the three of the 13 were interviewed for a few minutes
Mhm.
by the moderator, John Ankerberg.
Mhm.
And then the 13 published a statement because we basically commissioned them. Danny and I commissioned them. Hey,
Mhm.
just like the Jerusalem Council published a statement to resolve the controversy over circumcision.
Mhm.
Likewise, we had these 13 astronomers carefully analyze the 2 hour debate and then you'll come up with a statement. We asked them to reduce it to one page. They produced a 40-page statement with footnotes. We said, lay people aren't going to read that. So
Right.
skip the footnotes,
Mhm.
reduce it to, so the Jerusalem Council got it down to two sentences.
Yeah.
See if we can get it down to a single page. They
Right.
got it down to, it took them a year to get it down to a single page,
Mhm.
but it's on
Wow.
our website. If you go to our website at reasons.org and
Mhm.
you type in astronomer statement,
Mhm.
uh, their statement comes out. But their main point is you can't use a single anomaly to overturn an age estimate. You have to use a weight of evidence argument. Let's look at all the evidences, those that have no anomalies and
Mhm.
those that have a few anomalies. And that's how you determine the age of system. And they basically said, using that weight of evidence argument, the
Mhm.
evidence is utterly overwhelming that the universe and the solar system are billions of years old. And
That.
and I'm old enough as an astronomer
Mhm.
as I came to Christ through studying a Gideon Bible for 2 years,
Mhm.
and it took me another 8 years to meet somebody who thought the universe was only thousands of years old. Just
Mhm.
reading the Bible, I said these creation days have to be long periods of time.
Right.
And when somebody said, "Oh, are you a young universe creationist?" I said, "Well, yes, I am, because I grew up in my childhood. I was reading astronomy text since I was 7,
Mhm.
but that was a time when there was a huge debate in the astronomical community: is the universe quadrillions of years old or only billions of years old?" So
Mhm.
yeah, when I was first confronted by young Earth creationists, I said, "Yeah, I'm young universe. I, I believe it's only billions of years old."
Yeah.
But what's interesting about that debate, the
Mhm.
astronomers in the early part of the 20th century that were strongly promoting quadrillions of years,
Mhm.
they did it predominantly for philosophical reasons, not for
Right.
scientific reasons. They
Right.
said if it's only billions of years old, we can't save the Darwinian explanation for the origin and history of life. We need way more time. And they were appealing to models of stars that made it look like the stars were trillions of years old.
Mhm.
Turns out those models were incorrect. The stars are only millions and billions of years old. So,
Right.
yes, uh, a major debate in the astronaut community got resolved. It's a young universe. It's
Yeah.
only billions of years old.
Yeah. Yeah, definitely compared to what they thought in those days. You had this eternal universe model, that
Well,
Einstein.
that was earlier in the 19th century. They
Yeah.
thought it was eternal.
Yeah.
So,
So definitely a young universe compared to that. So,
right.
and I was going to ask you too about that because it leads into the issue of evolution. In the video from Creation Ministries International in particular, they want to tie that into evolution, deep time, Big Bang cosmology. They'll say things like, evolution is surprised by this, or evolution is wrong again. And evolution is a theory of biological science, whereas we're dealing with planetology, cosmology. Is there any necessary relationship between these things?
Well, young Earth creationists are convinced that there is a relationship between naturalistic biological evolution and an Earth and a universe that are billions of years old. And if you read their literature and their books, it's because they're convinced that speciation, natural selection, gene exchange, and epigenetics can rapidly transform species into new genera, new orders. Uh, that's core to their model because they believe that there were no carnivores until Adam sinned. And so they build into their model the rapid biological evolution of herbivores into carnivores. And they also invoke it again because they're convinced that the flood of Noah was globally extensive, not
Mhm.
just wiping out humanity, but wiping out everything on the face of the earth and
Right.
transforming the geology. And therefore, they have to explain how the millions of species of land life today evolved from the few thousand on board the ark or less. Now, to be careful about this, they never call it evolution.
Mhm.
They call it diversification.
Right.
But a number of atheist evolutionary biologists have said the appeal to diversification they're requiring for their young Earth model is
Mhm.
10,000 times greater than the degree of evolutionary change we atheists are claiming. So
Right.
they said, we're not the evolutionists, it's the young
Yeah.
Earth creationists. So,
Similar to that punctuated equilibrium, everybody used to, make so
right.
much fun of that idea. Yeah.
Well, it's only from an old Earth creationist perspective that
Mhm.
you can avoid that trap of claiming that life happens naturalistically. In an old Earth model, you do have naturalistic evolution taking place, but the new phyla, orders, and classes, they're there by the miraculous hand of God
Right.
and
One thing,
supported by the fossil record, incidentally.
right? Yeah, it makes sense. One last thing I'll ask you tonight. It kind of dovetails back to what you were talking about with cratering in the solar system. If all of the bodies that we see in our solar system and in the universe were created instantaneously as a fiat act only a few thousand years ago, what should it look like out there as opposed to what it does look like?
Well, again, several of my young Earth creationist friends admit this is a major problem for their model because their model would predict as we look out in the universe, the different bodies there are going to have ages that will measure between 0 and 10,000 years.
Mhm.
The truth is, they measure between 0 and 13 billion years. And so
Mhm.
we see this very wide spectrum of age measurements. And that's a big problem for the young Earth model. That's
Right.
one reason why they don't like to talk about white dwarf stars or black holes or supernova eruption events.
Mhm.
And particularly with white dwarfs are burnt out stars. They're
Mhm.
stars that are so old, they've gone through all of their nuclear fusion fuel. And
Mhm.
more than that, we can see that they've cooled down. And so when we look at large clusters of stars, we can see thousands of white dwarfs that are in different stages of cooling. And some of them have cooling times that measure more than 4 billion years. So they're not only burnt out, they've been cooling down for 4 billion years after they ran out of fuel.
Mhm.
A good analogy is the embers over an open fire.
Mhm.
That wood you throw in open fire, it exhausts its fuel, and then you have these embers that go from a bright red to an orange, finally
Mhm.
to a brown color, and eventually they go black.
Mhm.
But one reason why astronomers don't believe the universe is quadrillions of years old, we see no black dwarf stars.
Right.
The universe is not old enough for white dwarf stars to completely cool off.
Mm-hmm. And there are a number of things that too about that just never made any sense to me as a young Earth creationist. I couldn't figure out, why would God create black holes? Why would there be these other objects that we see? In fact, why would anything beyond about 6 to 10,000 light years even exist? I mean, it doesn't shed light on the Earth. It doesn't serve for signs and seasons, any of the things the Bible talks
Right,
about.
right.
So none of that made any sense to me. And just looking out there, everything does appear to be as old as science says it is. So I think we've
Well,
got good evidence.
just think of the elements in your body. I
Mhm,
mean, there's several elements that are crucial. If you didn't have them in your body, you would die. And
mhm,
where do those elements come from? Neutron stars merging together to become black holes make about a quarter of the elements in the periodic table.
mhm.
And many of those are vital for life to exist.
Right.
And so I actually wound up writing an article, God's Care in Black Holes. It
Mhm.
got published in a secular peer reviewed journal.
Yeah.
Black holes is evidence of God's care.
Wow.
And
What was the reaction to
basically
that
making
like?
a point.
What
We
was the
need to
reaction?
thank God for black holes.
Yeah. How did they react to that in the secular community?
Well, what I loved about this journal is the journal Religions, where they're actually
Okay.
soliciting scientists to talk about.
Mhm,
And I drew three reviewers.
mhm,
Two of them were clearly atheists and wanted to reject the paper.
mhm.
But what I loved about the journal is that they made public the statements from the three reviewers, and they made public my responses to the three reviewers.
Mhm.
And the two atheists just presumed I wasn't up on the literature on black holes. And so in my response, I talk about how I surveyed 17,000 papers on black holes. They
Wow.
were claiming, hey, these objects may not be black holes at all.
Mhm.
They may be soliton stars or neutrino balls. And I said, look, I've looked at the literature. There's only 8 papers published on neutrino balls and the soliton stars. And the reason why there's only 8 is
Mhm.
that those authors could not explain how you could have such bodies as stable bodies.
Right.
And yet we got these 17,000 other papers talking about black holes. We know we can make black holes stable. And given all the neutron stars we see, we know there's got to be a lot of black holes. So
Right.
they wound up conceding, and my paper got published.
Good.
But
Good.
and you could see the difference in the tone between the atheists and my response to them. So I was glad that they made all that public. In fact, the entire paper is available as free access to the public,
Okay. Yeah. Excellent.
and it's readable. I made sure that
Mhm.
it'd be readable to people who weren't astronomers.
Okay, good. Yeah, that's my issue because I love astronomy. I've been into it my whole life, but I'm a math idiot. So when I try to get into these things, and then suddenly the equations start, and I just zone at that point. I'm like, I'd love to do it, but I can't. So,
Well, a couple of courses in tensor calculus, and you'll be fine.
okay. I appreciate you coming on tonight. This has been good. I would recommend anybody out there who wants to follow up on your work, reasons.org. Your book, Improbable Planet, is absolutely excellent. I can't recommend that well enough. And you have another one coming out, Designed to the Core. Is that called? When's that coming out?
That got released yesterday.
Oh, okay,
So
good.
they go to our website at reasons.org. They can get a copy of Design to the Core.
Okay, excellent.
Yeah,
Thanks.
and I'm excited about that because I basically
Mhm.
said the fine tuning evidence for God is on all cosmic size scales, from the
Wow.
universe as a whole, all the way down to the interior of the moon, the Earth. In fact, I got a whole chapter on
Mhm.
asteroids and comets in the solar system
Wow.
and how each of those 5 asteroid and comet belts
Mhm.
must be highly fine tuned for advanced flight to be possible on Earth.
Mhm.
So come Thanksgiving, our family is going to be thanking God for those 5 asteroid and comet belts.
Yeah, sounds good. All right. Well, thank you again for coming on, and thank you for everything that you do. I know it's not been an easy journey in a lot of ways. You've been subject to a lot of criticism, a lot of friendly fire, quote unquote. So I really think you've been an excellent example of Christ-like perseverance in the face of that, and we appreciate what you do.
Well, thank you for those kind words.
All right. Thank you, Dr. Ross. God bless.
Thank you. Take care.